Good morning, I'm Dr. Huang. Today, I'm going to teach you a systematic method to write down the Lewis structures with resonance structures and formal charges. There are a lot of molecules and ions whose Lewis structures are very difficult to write down correctly. Here is a list of them. Well, if you can follow the procedures I'm teaching you here, it will be relatively easy and relatively fast to write down the correct Lewis structures with resonance structures and formal charges for any molecule or any ion. Well, let me choose carbonate as an example to illustrate the steps of this method. The first step of this method is to obtain a skeleton structure from your instructor. In the skeleton structure, a line or sometimes a dotted line tells us that there will be a chemical bond between the two atoms. However, I want to emphasize a line or sometimes a dotted line in a skeleton structure is not always a single bond in the Lewis structure. It can also be a double bond or a triple bond. If there's no line between two atoms in the skeleton structure, that means there's no chemical bond between the two atoms. The second step of this method is to place the valence electrons next to each atom. Each oxygen atom has 6 valence electrons. Each carbon atom has 4 valence electrons. You can find the number of valence electrons of any atom from a periodic table. Carbonate ion has -2 charge. Therefore, it has 2 additional electrons. Now let me show you how I place the valence electrons next to each atom. You can start from any atom. Let's start from the central carbon atom. From the skeleton structure, the central carbon atom has 3 neighbors. Therefore, we will need 1 electron for each of its neighbors. We will place 1 electron between the central carbon atom and the oxygen atom on the left. We will place another electron between the carbon atom and the oxygen atom at the bottom. We need to place a 3rd electron between the central carbon atom and the oxygen atom on the right. For the last electron, we will place it here. Make sure you don't place this electron between carbon atom and any of its neighbors. Well, let's work on the oxygen atom on the right. From the skeleton structure, it has only 1 neighbor, which is the central carbon atom. Therefore, we will take one of the valence electrons of the oxygen atom on the right and place it between the oxygen atom on the right and its neighbor. Then we will place the 5 electrons left from the previous step into 3 groups. When we place the electrons left from the previous step into groups, we need to form groups of 2 electrons unless we have odd number electrons. If we have odd number electrons, we will have 1 group with only 1 electron. All the other groups should have 2 electrons. We will do the same for the other 2 oxygen atoms. Well, you may wonder, Dr. H, where do we place these 2 additional electrons? Well, in general, we will place the additional electrons next to the most electronegative atom of the molecule or ion. In this case, it should be the oxygen atom. And when we place the additional electron next to the most electronegative atom, we only add 1 additional electron to each atom. Since we have 3 oxygen atoms, but we only have 2 electrons, you may wonder, how do we choose? Actually, it doesn't matter which 2 atoms you choose. Let's choose the oxygen atom on the right and the oxygen atom on the left. Every time when you add an additional electron, you put a -1 formal charge next to the atom. The next step is to replace the shared electrons between the 2 atoms with a stick, which means a single bond in the Lewis structure. The goal of our next step is to make sure every atom will have either an octet or extended octet, since both carbon atom and oxygen atom belong to the 2nd period. So, none of them can have an extended octet. Well, to get an octet, which means each atom will have 8 octet electrons. Now let me explain what are octet electrons. Well, the electrons we placed next to an atom are octet electrons for that atom. The octet electrons include lone pair electrons and shared pair electrons. The lone pair electrons are not shared between atoms. They are only counted as octet electrons for one atom. The shared pair electrons are between two atoms. They will be counted as octet electrons for both atoms. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. This is good. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Well, remember our goal is to make sure every atom will have an octet or extended octet. For this particular case, we want every atom has an octet, which means we want every atom will have 8 octet electrons. When we look at this structure, we find that this carbon atom and the oxygen atom at the bottom only have 7 octet electrons. We need to increase the number of octet electrons. Remember, there are 2 ways and only 2 ways to increase the number of octet electrons. One way is to share, which means each atom will contribute an electron to form a shared pair. When we are sharing an electron pair, the number of octet electrons for both atoms will increase by 1. And it will not create any formal charges. To borrow means one atom will get 1 electron from its direct neighbor. This is called to borrow. To borrow will increase the number of octet electrons of one atom. It will decrease the number of octet electrons for the other atom. Plus, it will create 2 formal charges. Therefore, we prefer to share an electron pair than to borrow an electron. We only borrow an electron if to share an electron pair will create a Lewis structure that will violate one of the rules of the Lewis structures. Well, let's try to share. Let's count the number of octet electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Both of them will have 8 octet electrons. Well, from what we have, it seems every atom have an octet. Then this should be a good Lewis structure. But let's replace these 2 shared pair electrons with a stick, which means another bond. Well, from the Lewis structure we just get, it has 3 bonds. One of them is a double bond. 2 of them are single bonds. Remember, if a Lewis structure has 2 or more bonds and at least one of them is a double bond or a triple bond, we should try to see if it has resonance structures. Actually, it does have 2 more resonance structures. Now let me explain how to get other resonance structures from the Lewis structure we just got. In general, all resonance structures should have the same number of bonds and the same number of lone pair electrons. The original Lewis structure has 1, 2, 3, 4 bonds and 1, 2, 3, 4, 5, 6, 7, 8 pairs of lone pair electrons. Therefore, the other resonance structures should also have 4 bonds and 8 pairs of lone pair electrons. The first step is to rearrange the bonds. There are 2 more ways to rearrange the 4 bonds. Let me show you both of them. This is one way. This is the other way. The next step is to place the lone pair electrons next to the non-central atoms to make an octet for each non-central atom. If you have any lone pair electrons left, you will place them next to the central atom. For this particular case, we do not have any lone pair electrons left. Therefore, we do not need to place them next to the central atom. Let's do the same for this resonance structure. Well, remember, we're not done yet. We have to calculate the formal charges of all atoms. If the formal charge is not 0, we have to label it explicitly. Well, after our calculation, we find that the formal charge of the oxygen atom at the bottom and the formal charge of the oxygen atom on the left of the first resonance structure are -1. Therefore, we will place -1 next to each atom. The carbon atom and the oxygen atom on the right has 0 formal charges. Therefore, we do not need to put down anything for them. Well, after our calculation, we also know that the formal charge of the oxygen atom on the right and the formal charge of the oxygen atom at the bottom of this resonance structure are -1. Therefore, we put -1 formal charge next to each oxygen atom. The carbon atom and the oxygen atom on the left has 0 formal charge. Therefore, we do not need to put down anything for them. Well, if you're asked to give me the Lewis structure of the carbonate ion during exam or a quiz, you can present your answer in 2 different formats, either in triangular format or in linear format. Your answer must include all 3 resonance structures with all non-zero formal charges labeled correctly. You must also include double arrows between resonance structures. The double arrows tell us that this is one Lewis structure of 1 molecule or 1 ion, not 3 Lewis structures of 3 different molecules or ions.